Right. So earlier we were describing one of the challenges that sometimes we need to explicitly be able to specify what are the steps that we want to follow to update or insert. We would like to be able to programmatically specify what happens, right? We want to, step by step override or at least be inserted into the process by which the database updates or inserts or deletes data, right? So stored procedures allows us to insert ourselves into the life cycle of how data is updated in the database, right? We could ask to be notified, when certain events occur, right? So that we could maybe abort or maybe modify or just place ourselves in the process of the life cycle of the data, right? It also allows us to, step by step, be able to specify what are the actions to take that we want, how we want to manipulate data. So stored procedures allows us to basically create a program in the full sense of the word, right? So all the expressive constructs that you would expect from a full-blown programming language, right, is available inside of a database, right? And certainly it's one of the benefits of writing stored procedures is that you can't get closer to the database, right? You are running within the environment of the database. So certainly they're very, very fast performant, and they're optimized, for by the vendor, to take advantage of the way they internally store and represent the data. Okay. In contrast, one of the problems with stored procedures, one of them is that you're buying into a particular vendor, right? So whatever features that stored procedure in that particular language, that particular environment, you're buying into that particular infrastructure, right? So any considerations of migrating away from that vendor, upgrading to a different vendor or whatever, just makes it that much harder, right, to move away from that. Okay, and certainly vendors, whenever they sell you these databases, they'll tout all the great things about using that particular stack, that particular environment, and so this is their chance to shine beyond the SQL standard, right? Because yes, most databases are pretty standard on the SQL that they support, right? But certainly in stored procedures, they get a chance to really go beyond the standard, right? All the great things that they could allow, and they'll sell you a lot, upsell you to try to stay, for them to be able to stick with them for a long run. Yeah, so it creates an abstraction layer of the table, right? So that you can deal with the low level idiosyncrasies of accessing the table, but hiding it beyond a nice API. You can just call it, right? And then inside of that API, inside of those functions, you can then do all the nitty-gritty of dealing with the database, all abstracted with a nice interface. Okay. And you can also do fairly complex logic, right? That depending on different business rules, whether you can allow certain operations to go further or not, right? It's the fastest you can get to. The database is definitely harder to maintain. Doesn't have as much support from a wider audience of open source developers. You're buying into a particular stack. that might not be as well supported as other stacks. Now, there are different types of store procedures depending on when do they get executed, right? Some of them are executed by you specifically invoking them, right? Either from the command line or from an API from like Java or some other, where you can call a function, get a hold of that function, and then explicitly call it and pass it parameters, or whether they execute implicitly based on certain events that occur, right? So, for instance, we might want to have a procedure be execute every time we insert into a table, or every time we update a table, right? Every time we delete a table, right? We would like for certain events to implicitly invoke these procedures, as opposed to us explicitly running it, right? So some of them are implicit, some of them are explicit. Yes? So functions are explicit. So functions and procedures are explicit. We are explicitly invoking these and passing some parameters, whereas triggers, right, are procedures that are invoked when a particular event occurs, right? Okay. So they also, some of them, depending on when they get executed, they might change data or not. Functions are not meant to modify data, whereas procedures and triggers are. Triggers are very powerful, allow you to intercept, right, a modification of a table. For instance, in the insert, when you're inserting data into a database, obviously you have certain constraints, right? You can say this cannot be null, this is a primary key, this is a foreign key, this has to be a date, this has to be an integer and whatnot. So there's a lot of validation that already is in place by you just creating the schema, right? But you can go even further, right? By a trigger. You can say, well, all right, so the schema is going to take care of the simple validation, okay? But I can have even further validation by creating a procedure where if I can get a hold of the data that I'm trying to insert that has already passed all the validation of all the constraints by the schema, but I want to look at it and run a procedure that can validate things. Maybe you can't, I don't know, maybe you can't insert an order between certain dates or between certain times. So I would like to calculate what current time it is and allow or disallow whether you can create this record or not, right? Or I might look you up and my business says that, my business logic might be that depending on how many orders you've made this month, I might want to give you a discount. Okay, so these business logic, right, these rules can't be implemented in the constraints, right? They need, additional queries. I need to look at your history, your order history, right? I need to do some, to calculate whether I can give you a discount or not. Yes? So all this needs to be programmatically added in a procedure, and it could be done on trigger, right? When you're trying to insert data or maybe update data. I like to execute this piece of logic. Functions, they can return data. They behave like what the name suggests as a function. They don't have side effects. They return data that can calculate and part of a statement. They can be part of a statement. Procedures depends. So you can have procedures that don't return any data, or you can pass in data or have only output data. You can say in or out, and they can change data, and you can execute them at the command line. So here's a couple of really simple procedures. Here's a hello world that you use the create procedure function, create procedure keywords, and then you can assign a certain set of actions to it, right? Here you have a select a hello world, right? And this creates a result set that has the name of the function of the procedure and then the results that comes back from the query. Now, because this has a completely different syntax, right? It doesn't have a data creation syntax. Oftentimes, you need to escape the creation of this, right? Because this select statement here, we don't actually mean for you to select it now, right? It means that when it executes, the select statement will run, right? Once we run it, right? Not immediately, right? It will only execute when you call the hello world. So typically we would use delimiters such as slash slash or at, or you can choose any delimiter to say, hey, everything's SQL, but this is programs, right? So almost like if you're on ASP or JSPs or PHP, right, where you need delimiters to determine that, hey, this is HTML, but this is PHP, right? So this is to be able to distinguish the syntax, right, and the intention on how to interpret what you're typing, right? So delimiters allow you to go back and forth between just plain old SQL or plain old programming, right, and creating the software. Obviously, you would typically use an IDE, right, that would allow you to have an entire, development environment where you can only type just procedures, right? You can edit all the procedures all without any of these delimiters, right? Obviously, right? Now the syntax is a little bit different between the various vendors. Again, each one will try to sell you, their particular improvements on the idea. MySQL, you can call the stored procedure just by name, just call hello world. You can pass in arguments, whereas Microsoft, you use exec or execute. Okay. Again, they're slightly different vendors. You can alter a procedure using just alter procedure, and then you can either drop it or add to it or modify it. Again, you would typically use an IDE, right, inside of your vendor where you can then edit it. Here we're altering it, and we are just replacing the original implementation with a new implementation. Here's a really simple one that returns a value that can then, but in this case, we are assigning it to a local variable that can then be reused in subsequent queries, right, where we are executing a select statement that executes and displays the intermediate results when it's executing, but the whole thing evaluates to a whatever we return. Here in this case is 1, 2, 3, which we are assigning it to a local variable return value, first declaring as an integer to be able to hold the value that's being returned, and then we are then just to display it, to echo it, we are selecting it and displaying the value. Here's a couple of other trivial examples where we have two selects. Each one, these are all intermediate results, right? So you can have fairly complex procedure that you can run, and it will just maybe generate a report of some sort where you can quickly see some intermediate results before evaluating to an actual value. Here we have a select statement that we can parameterize. Well, not this one. We're not passing any values, but we could certainly pass the 2000 as a value for a parameter, so that we can call the procedure and pass in an argument that can be then used in this where clause. So here is the return of that select statement. Now you can pass parameters using in parentheses. You can declare inputs, right, that can be fed into the query, or you can also declare outputs. So you can have variables that are only going to be used for inputs, meaning you can't write to them inside of the procedure, right? Any modification will be lost. Or variables that are meant only to be set inside of the procedure and then can be used outside of the procedure as results, right? Or variables can do both, in, out. Okay? So you can declare them this way. So the in is already the default, right? So that's an option. You don't need to declare in. If you don't declare anything, it's understood as an in variable. So here's an example of being able to pass an attribute, a function, a parameter to a procedure. So here we're declaring var1 as an input, and we're passing a 10 to it. And so we are resulting, we're just calculating the result of adding a 2 to it. Here we are declaring an out, so we can set the value, and then that variable can then be used outside of the procedure by name. Here's one where it can be used as both in and out. So outside, any variables that we might have passed in as an argument will have the new value of the variable. Otherwise, var1 would have been a local variable that would not be accessible outside of the procedure. Okay. So this is kind of being able, almost declaring private and public, right? So it's different syntax, but it's almost basically the same idea, right? Of what is the scope, right, of these variables inside or outside, local versus global. Here we're declaring variables that would be available across the entire session, right? As we log in, these variables would live through the entire session, so you can refer to them at a later time, right? If you open up different windows, you can refer to that same variable across the entire session. So here we have a variable that we are first setting it to 10. We pass it as an argument, and then we receive that it's so it's kind of like pass by reference. We're passing it, it's setting it, and then we have access to the results of that variable. All variables declared inside of the begin and end are local variables, right? So they're not accessible outside. So here we have just a couple examples of declaring several variables inside of the begin and end with different data types, integers, variables, timestamps, and whatnot. And you can use set and select to set the value. So here's an example of creating several of these variables instead of a begin and end. And we're doing various operations. We're inserting into a table. Then we're querying that same table. Table 1. Okay, no. We're just setting the value, concatenating, and then retrieving values from it. And so we're using the variables across all these operations. So this is just an example on that if you do declare a session variable inside with the @ sign, right? That is kind of like a global variable that is available all across the entire session. So here we're selecting var2. We are updating it, and then what are we doing here? var2 is being initialized to be 1. We increment it to 2, and then we're setting variable 2 to be var2, which is 1 at first. We're incrementing. Okay, so we're able to see the global variable 2 at variable 2 even within the procedure, right? It's almost like a global variable. Yep. And we keep calling it multiple times. We'll notice that var2 doesn't change. It's always 2 because it's a local variable as opposed to at var2 is a global variable, and we are just keep incrementing it over and over and over every time we call the procedure. Inside you can have a fairly complex. You have access to full-blown programming language. You have if statements, whiles, select, where. You have all sorts of powerful structures, right? So here we can just do if else. We can select inside of the else, inside of the if statements, which is pretty cool. So you can embed all these select statements and inserts and updates, right, inside of these if statements. Like we can have implement entire business logic, right? Look at the dates, the times, whether certain conditions apply, whether you are going to indeed select or insert or update based on those cases in business logic. Same thing with a case. Again, you can use a when case that is going to be comparing the variables against multiple when clauses, and the one that is true, it executes that one. It doesn't behave like the select statement in other languages, where the first one matches and then it executes all the ones afterward. This only executes that one. It's a combination of a case and then a break, right? It only executes that one insert. Okay. This is a little more powerful, where the when clause can actually have a predicate, right? So each when clause can have its own individual predicate, as opposed to this where you have one variable compared to several literals, right? Here you can have, the when clause can have its own Boolean expression, right, and could be completely independent of each other. Although the first one that matches, that's it, right? It doesn't keep comparing all the other ones. You can do loops. You have, like while do loops, and repeat until, that can compare variables and then just keep inserting. Do lots and lots of inserts and just populate an entire table based on certain conditions, right? You can just iterate and do lots of inserts into a database. So it's pretty cool. Repeat here, we're incrementing the global x, until we reach a particular parameter, right? And we are just, again, this could be updates, inserts, deletes, right, based on certain procedures. Okay. Same thing, loops allows you to loop and then jump, almost like a go-to, that you can jump to a particular case, like a particular label. Yeah, a full-blown programming language.